In this video, we're going to look at how the change parameter gets added and what it means. So suppose we have an example like this where we have a test composable method with one parameter, which is an integer. What we want to do is to be able to add in the composer parameter that we looked at previously, and we also want to be able to add in this change bit mask. The way the transformer is structured is that it visits all of the methods that are part of your code, and it checks whether it has a composable annotation before doing any modifications to the parameters. The way a modification is done, the way a parameter gets added, is by utilizing this add value parameter extension. And here I'm going to specify the name of the parameter that I want to add and the type of it, whether it's nullable or not. So that's what we looked at previously. Now we're going to look at how the change bit mask gets added and what it means. The change bit mask is used to represent any changes in the real parameters. In this case is the x variable, the x integer type. So in order to determine how many change parameters you're going to have, you need to take into account the total number of parameters you have, the total number of explicit parameters. So how do we get the total number of parameters? And we're also going to look at how it allocates the different bits for each parameters. How many bits does it allocate for each parameter? There are two types of parameters, implicit and explicit. Implicit parameters are things such as, context receivers. So you could get the context receiver count just like this from an IR function type. What the compiler plugin does is that it creates an extension to get the total parameter count. And this parameter count is the number of implicit parameters, which is the context receiver parameter count, if it has any, or you could have like dispatcher receiver parameter or extension receiver parameter. These are all different types of implicit parameters, and it gets a total number of these types of parameters that you have. But it also has to get the total number of explicit parameters, which are actually like integer variables that you pass in. So how does that work? First thing that the compiler plugin does is that it gets the total number of current parameters, and it figures out the number of real parameters by subtracting away any implicit parameters that you have. So what it does then is that it takes that information to determine the bit mask, to determine how many change variables is going to need. So first you get the information on the total number of parameters that you have, implicit and explicit. So what the changed value is the bit mask, and it's a 32-bit bit mask. And the last bit in this bit mask, it allows you to force recomposition of this method. And the other bits are used to store information whether a parameter changed or not for each variable. So what the compiler plugin does is that it looks at all your parameters. Suppose you had not just one but multiple integer values that you're passing in. All of them get allocated a specific number of bits. So imagine a linear array like this of a size of 10. So you have 10 slots per int. You have 3 ints in that case. You have x, y, and z taking up the first 3 slots, and they take up 3 bits per slot. So that's what you have right there. You get 3 bits per slot in that change bit mask. So how do you figure out how many change bits to create? You could have multiple changed variables. So the way the compiler plugin does is that it has a method called change parameter count, which takes in the total parameters that you have, which are implicit parameters and your real parameters. It takes a total of that and it performs a division. So it divides it by this total number of slots per int. And what you get from that is a number of change parameters that you could use, that you will need. So in our case, we only have one x variable, so we only need one change parameter. So the way you add this is like this. It does a for loop, because you could have multiple change parameters depending on how many variables you have. And I'm adding the number of change parameters by using the add value parameter method, just like this. And you can see they all get numbered with a suffix, which is what that index I is used for. So in this example, you only need one changed bit mask for this. But what if you had about 14 different variables? If you had 14 different if you had 15 different variables and you perform this division, you will need about two because it's 10 ints per slot. So you will need two change parameters just like this. They will basically generate these two change parameters and we'll add them. So when you look at that's what the chain bit mask is. Now what I need to be able to do is that I need to be able to traverse these nested methods and pass along this change bit mask and the composer to it. How do you do that? The way you do that is that there is an extension that the Kotlin compiler provides called transform children void. And what it is that it allows you to add in an element transformer. And as you saw before, what this element transformer is, it's an abstract class that has a lot of visitor methods, and I could selectively override which one I'm interested in. So what I'm interested in is being able to traverse those nested functions, which is where visit function is going to get called. And I could perform the same transformations that I did to the outer function. I could check whether it has a composable annotation. Are you calling a composable function? And I could do any form of transformations on them. I could also visit each call in there, and this is where I add in the compose param and the change param. So it's recursive. It goes through the nested calls and it updates their parameters. And in the end, what you get is this right here. So this is how the change parameter and the composer get added. Next, we're going to look at how all this other code gets added, which is used for being able to skip a composable function. We'll look at how this and or is being used and why they're being used in that way.